Hello, today we will discuss environment variables. I think already we heard this term in previous units. Environment variables are nothing. These are the variables which are set when the user is logging into the system. And these variables are set by the kernel. We will have one statement related to this here. The environment strings are usually of the name equal to value. The image kernel never looks at these strings. Their interpretation is up to the various applications. Means the environment variables is always taking as of the form name equal to value. Just like you might be remember the one of the environment variables shell. Name of the environment variable is shell. What is the value? C shell, B shell, K shell, like that. Usually we have a PWD. So it is also one of the environment variable. Print working directory. If I have printed that one, we are listing the current working directory of the user. Yes, and path is one more environment variable. Like this, we are having many environment variables here. The cells, for example, use numerous environment variables, like as I use the code and user asset manipulate login, and others are for us to set. So this means that these variables are set when we log in into the system. So the point is already highlighted here. We normally set the environment variables in shell starter file to control the cell sections. The function that we can use to set and fetch values from the variables are set environment, get environment functions. So that means using these functions we can handle the environment variables here. So as the name indicate get, we can retrieve here. So that get environment name means if I use the code here, it will pointing to the one of the environment variable having the name is 4. And what should be the return value? Return value is pointer to value associated with the name. Nothing but it is pointing to the address location where the value of the environment variable is stored. Okay. Otherwise it will return the null value if not succeeded here. Put environment. So as the name indicate, this function just takes the string is of the form name equal to value and places it in the environment list. If already this old definition is first removed and new one will be set. That means using the put environment variable, we can add the new environment variables is of the form name equal to value. Okay. So, and places in the environment list. I mean already we discussed the environment list. So in that environment list, we are placing this name equal to value here. And next set environment. It set the name equal to value. If already name exists in the environment, then there is a different operation. Okay. So this one, with respect to particular environment variable, we are adding the value, or just we are modifying the value of that environment variable. So it depends on the third argument rewrite. If rewrite is non-zero, the existing definition for name is first removed. If rewrite is 0 and existing definition for name is not removed, name is not set to the name value and no error occurs. Means if the rewrite value is other than 0, it will be removed and added as a 1 second. If rewrite is 0, the existing definition for the name is not removed, only we are adding the value. Okay. One more is unset environment. This function removes any definition of the name. It is not an error if such a definition does not exist. That means it will remove any environment variables from the environment list, like is of the form name equal to value here. Whereas set environment must allocate the memory to create is of the form name equal to values. Whereas put environment is free to place the string path directly into the environment Means set environment first allocate the memory, then add the name equal to value. Whereas put environment, it is free to add the environment variables to the environment list. If you wanted to modify an existing name, the size of the new value is less than or equal to size of the existing value, you can just copy the new string over the old one. That means, if suppose if I take the hope is one of the environment variable, it is having the some values. I wanted to change that environment variable value to some new value. The new value length, string length is same as the existing length, then no issue. Just we are adding the new value to the existing value. If the size of the new value is greater than the old one, we must call the malloc to obtain the root for the new string and copy the new string to this area and then replace the old pointer in the environment name with pointer to this allocated area. That means the new string value is larger than the current one. Next we are calling the malloc function. There is a space is allocated. In that space we are copying the new string and then place the old pointer in the environment list for the name with the pointer to this allocated area. Means the existing new pointer will be added to the list. If you are adding a new name, it is more complicated. Means when you wanted to, there is not at all any environment variable exist. I wanted to add it here. So in that case, first we need to call the malloc to allocate the row for the name equal to value string and copy the string to this area. Then, if it is first time we are adding the new name, we have to call the malloc to obtain the root from the new list of the pointers. We copy the old environment list to this new area and store a pointer to the name of the value string at the end of the list of pointers. We also store a null pointer at the end of this list. Of course, finally we set the environment to point to this new list of the pointer. That means, if I am adding the new name, we will call the malloc. Then we copy the old environment list to this new area. The space is not sufficient. Then the newly allocated string list pointer is pointing to global variable called n1 here. And every string is terminated by the null pointer, null value. If this is not the first time, we are not adding the new name first time, we are adding repeatedly the new string to the environment list we are adding. Then we know that we have already allocated the root for the list on the heap. So we just call the realloc to allocate the root for one more pointer. The pointer to new one name equal to value string is stored at the end of the list. Means every environment variable is adding at the end of the environment list, which is followed by null pointer. And I'll show here. I'll show here. This one is just we can check it here. This is what I can call as an environment variables. These are the environment list variable we are adding to the environment list by using those functions. Next, we are having setjmp and longjmp functions. You can see we cannot go to a label that is another function. Instead, we must use the setjmp and longjmp functions to perform this type of the branching. To prove that, suppose there is a one function name we are calling. In the main function, we are calling the one user defined function called as the add. If something is went wrong in the add function, we cannot come directly to the main function. We can't transfer the control back to the main function by using goto label. So to overcome this problem, we are using the setjmp and longjmp functions. As we will see, the prototype these two functions here. The setjump is having the one argument, jump buffer is a high, and one is actually variable or argument whatever. So this function is returning 0 if called directly, otherwise non-zero if it returning from long jump. Means if I call through long jump function, next the setjump will take in the different return value. So here long jump is having the two arguments, one is n1 and n1. How it works, the n1 is record the necessary information needed to continue execution. N1 is of the jump buffer defined in the setjump defined. And value is nothing but the integer value that we are returning to setjump function when it called directly to long jump. We see examples are more important here. How it works. You consider the main function. So as I called setjump function buffer. So if I call directly, it will return the 0 value as we know. So printf of Greek 3 is not executed. It will execute the else part. So in this case Greek 4. Just we can go through here. Greek 4 output we got it here. Next we are invoking the function. See that the function here. Here welcome to Greeks. For Greeks, this one we got it the output. And long jump here. This one we got executed. Yes. So when we executed this statement, that means the control is not executing this statement here, rather than it is returning to main function here. Once again it is executing the setjump here. So what the setjump is containing now? The return value of the long jump. What is the return value? That is the 1. If this what value we specified, that will be the return value. So it will be taken here. So that means if of 1. If of 1 means this statement is executed. That is 3 things. See that the output. So what we need to understand is that by using normal Bluetooth statement, we can't transfer the control from one function to another function. To overcome that problem, we are using the setjump and longjump function. As the name indicates, set, jump and long jump. So anything, any error or any kind of things occur, we can transfer the control from that particular function to main function. I hope you got the point what I am explaining here. Thank you. We will discuss some more